Hi, in this video we are going to cover one more data structure of Redis, which is set. You might have used sets in various other different languages like Python. In Python you generally use set command to create set and do some operations in it. In Java you have hash set. So similarly in Redis also you have sets which you can use. So in simple terminology, set is kind of like a bucket where you keep putting stuff into it, and you can't put duplicate stuff into it. So yeah, set is very powerful and it provides you very fast operations on it. Like let's say you want to check whether that particular element exists in a set or not, you get a fast lookup. If you want to remove any element, you get that very fast operation, right? And also it rejects duplicate automatically. You can't put duplicate stuff in your set, and also it's unordered. We also have an ordered set as well, which we'll cover in the next video, which is a sorted set. And let's say if you want to check whether this particular element exists in your set or not, you get a very fast lookup. So these are some of the advantages of set, and these are just some examples which you can try on set. Let's say you want to add a particular element in your set, you can use set add command in Redis. If you want to get all the members in your set, you can use set members. We'll also do these operations one by one, in the terminal, so that you get hands-on experience. And in the end, we'll see how Redis actually stores your set internally, right? What encodings it uses. So why does sets matter, right? In production, you can use sets for various purposes. Like let's say you have a platform where so many people are coming online, and you want to see how many people are actively online right now. So let's say you want to check how many people are currently online in a platform. So what you can do is you can put all your users in a particular set, and whenever someone comes online, then only you will be putting that user in the set. If user disconnects, you just remove that particular user from the set, right? So you can just directly check if user is present in set, that means it's online, right? And let's say you have some articles and you want to see what tags a particular article have. So you can maintain one set per article, and every article you can keep some tags, right? And let's say you want to see mutual friends between you and the person you're following. So in Instagram, right, or in Facebook, whenever you follow someone, you see a mutual friend list that you have so many mutual friends. So this also you can do with sets. So what you can do is you can put your followers list in a list, and similarly put the other person followers list in a separate set. And what you can do is you can find the intersection between both sets. That's how you will be getting the mutual friends, right? So there are so many scenarios in production where you can use sets, and it's very powerful in those cases. Now let's do some hands-on experience on some of the basics commands that Redis provides you. And I think these are the basic beginner commands that everyone should know if they are dealing with Redis every day in their production, in their software engineering life, right? So let me open my terminal, and here what I'll do is I'll start my Redis server. So you can write Redis server. It will start your Redis server. In the new terminal, you can open your Redis CLI. Here we will be executing some commands on the set. So the first command is adding particular elements to your set. So yeah, let's do this example. So we will keep a set of online users, right? So what you can do is you can open your terminal, and let me just copy this command, right? And in the terminal you can just paste it. So what here I'm doing is I'm saying set add. This is my set name, online users, and in this I'm putting 3 users, and all these users are different. Everyone has different user ID. So right now these users are currently online, right? And if you want to see how many currently active users you have, you can check the length of this particular set. How do you check the length? It's scard command. So let's run that. So you can write scard online users. It will it will give you 3. So that means you have currently 3 online users, right? And you can also check if that particular user is online or not. So let's say I want to check whether this particular user is online or not. So you can use SMEMBER. So this command is used for basically checking if that particular element exists in your set or not. So you can write S is member, the name of your set, which is online users, and then you can write which user you want to check. Let's say I want to check user 42. So as you can see, it gives me 1. That means this particular user is present in my set and it's online. If I provide any other user which does not exist in set, it will give you 0. So that means this is not online, right? And if you want to remove any element from the set, for that we generally use SREM, right? So let's say someone from these users disconnect and now they're not online. Let's say this 99 user disconnects. So what we'll do is we'll remove it from the online users list. You can do SREM online users, and here I'll provide the user which I want to remove, which is user 99. Cool. There's also one more command which basically gives you all the members that are present currently in your set. So let's also execute that. So as you can see, we removed this particular user, so it should not be present in my set. You can also confirm it. You can write SMEMBERS. So this gives you all the members that are present in your set, right? So as you can see, right now we only have 2 online users, right? So in production, you can use it in this way. This was just one example where we were maintaining online users set, right? Cool. And there are some other set operations as well, where sets are really very powerful. So I told you one example, using sets you can find out mutual friends, right? So we can discuss that example. So here we have 2 sets. One set is containing let's say Alice followers, and second contains Bob followers. If you want to find out mutual friends between these 2, you can use S intersection. So let's discuss this example. So let me execute this command. So here what I'm doing is I'm creating a followers set for Alice. So Alice has 3 followers, Bob, Carol, Dave, right? And I'll also create another person followers set. I can just copy this command, and here I'm creating one more set where I'm adding Bob followers. It's Carol, Dave, Eve, right? So let's say I want to find out mutual friends. So you will be doing intersection between these sets. So you can write S inter, and then you can provide the name of your 2 sets. So first is followers Alice, and second is followers Bob. So what do you think it will give you? So if you check yourself, so you have Carol is common, Dave is common. So you should be getting 2 mutual friends. So as you can see, for both these person, 2 friends are common, right? You can also do union. So let's say you want to find out everyone who follows both, basically Alice and Bob. So you can just do S union. So you can just do S union followers Alice, followers Bob, right? So it will basically combine all the followers of both these sets, right? You have another command as well, using which you can find the difference. Basically it will tell you, so in this command you are doing difference between Alice followers and Bob, which basically means the person who is following Alice but not Bob. So in this case you can see Bob is following Alice, but it's not following, you know, him, Bob. So you can do S diff followers Alice, followers Bob, right? And then yeah, I think these are some of the operations that you can perform on set. And this is one extra command where you want to store the result in new set, which is useful for caching expensive computations, right? We can also try these examples. So what here we are doing is we are storing followers to a new basically set. So here what we are saying is find the intersection of, you know, both these followers set and store them into a new set, right? So let's do this as well. I can just copy this command. I'll also explain it. So it's saying find the intersection and store it in this new set. So basically we are storing the intersection of both these follower set into a new set, right? You can also check it as well. So if you write SMEMBERS common followers, you'll see you have a intersection of both these followers into a new set, right? So these are some of the commands, and I hope all the commands were easy to understand, right? So in this way we discussed some real world examples like mutual friends, right? You can also do it with respect to articles, right? So if you want to see all the articles that are tagged with Redis or databases, obviously you will be using SUnion of tag sets, right? And let's say you have a product catalog, you want to see which products are in catalog A but not in catalog B, so you would be using S difference, right? And also there are some trade-offs. All these operations are O and M in the worst case, right? So make sure whenever you're using it, don't use it on the huge ones because it's going to block your Redis event loop, right? And there are some other commands as well, like let's say you want to get some random members from your set, so Redis provides you some commands as well for that. So let's discuss the same example. So let's say I want to get a random follower from ls followers. So what you can do is you can write SREM member, and I want to get a random member from ls followers. So you can just run this command and you'll see you got a random member from the ls followers, right? If you again run this, you'll see every time when you run this, you get a random follower from the ls follower set, right? If you want to get 2 random followers, you can also mention the count as well after this command, right? So as you can see, every time when I run this, you get unique random followers, right? And you can also remove a particular element from the set. So you might remember that we discussed SREM, but what's the difference between SREM and SPOP? That SPOP gives you the element which it removes, but in SREM we also provide which element we want to remove. SPOP is basically generally just to remove any random member. We don't specify here which member we want to remove. In SREM we used to specify, okay, remove this particular element, but in SPOP you generally don't write which element you want to remove. It just removes any random element, right? So you can just also execute this. So if I write SPOP and I want to delete one follower, any random follower from ls followers, so you can see it removed Bob. If I check members now in ls followers, you'll see it has only 2 followers now, right? So yeah, these are some of the examples that you can try out on your set. And yeah, these are some of the examples where sets are actually used in production. You can use it to find out who's online in your website, which we already discussed. You can also see what tags are present on your article, how many unique visitors are there, right? So there are so many examples which you can try in your production using Redis sets. Cool. Now the final part which we want to discuss in this video, which is very important, how Redis stores set under the hood, right? This is where it gets interesting. So in the previous videos, you remember we discussed string encodings, and string internally are stored in 3 different encodings, right? And sets also have 3 different encodings which Redis uses. So the first one is intset. So let's say in your set, all the elements that are there are integers. So Redis will try to optimize the memory and it will give it intset encoding. You can also check it. So let's say I create a set of popular scores, and in this I have 3 scores, right? And if you check the type of this element or key, you will see it's a set, but internally Redis gives it intset encoding. You can also check it. So you'll write object encoding popular scores, and here you can see it is using intset encoding, right? You can also see the memory it's using. If you write memory usage popular scores, so it's almost 62 bytes that it's consuming in the RAM, right? So why does it matter? So let's say you have 100 small integers, and if you're storing them in a set, it will consume very less memory, because Redis automatically will convert this particular set into intset, which is kind of like a compact set of integers, right? It doesn't use hash table or pointers internally, so it is saving you a lot of memory, right? Because if Redis were to use hash table for this, it would be consuming a lot of memory, right? And then you have listpack. So listpack is generally used when you have a bigger set, or let's say you combine strings in it, right? So yeah, you can discuss this example. So let's say I have a set where I'm storing tags, right? It has 3 tags, right? If you check the object encoding of this, you'll see it's now listpack, right? We already discussed listpack in the previous video. If you don't know it, or if you want to know it in depth, you can check out that video, right? So yeah, listpack is also like a compact sequence of bytes, right? And whenever you are storing strings or combination of strings and integers in your set, Redis will use listpack, right? But also Redis has some threshold, like you can also check it in your Redis configuration file. So in Redis configuration file, you have a lot of settings, and it has settings for this as well. So if it crosses this particular threshold, Redis will promote this encoding to the next encoding, which is hash table, right? You can also check it. So let me check it. So what you can do is you can write config get, and you can provide the configuration that you want to get. And here you can see we have 128. So basically you can store 128 elements in your set, and if it crosses the 128 threshold, it will promote this particular encoding to the next encoding, which we will discuss now, which is hash table, right? So hash table is generally used for larger or diverse sets, right? So if you have a very huge set which contains more than 128 entries, right? So it will be using the hash table, right? And in hash table, what it will do is for every element that you're storing, it will store that using STS, which we also discussed in the string video, if you remember. So every string object are stored as a STS, right? And along with STS, it will also create a hash table entry. So as you can see, it's consuming a lot of memory. It's creating STS for each member and also hash table for each member. So yeah, it's very highly memory consuming, but overall it's only taking up like O1 lookups. So it's also very nice, right? And also conversion is one way. So once a set is promoted from the lowest encoding to the higher encoding, it can't go back until unless you delete a key, right? So this is also one trade-off in Redis. And there are some thresholds you can check. Like you can check how many entries you can store in an integer set. Let's say you have all integers in your set. How many integers you can store in a set before it actually goes to the higher encoding? You can also check it in your Redis configuration. What you can do is you can copy this, you can write config get. So you can almost store 512 entries in your set. If it crosses that, it will be converted to listpack, right? And this one we already checked how many entries you can store in your listpack set, right? And you can also check like if let's say in your listpack, basically it wants every member to be less than 64 bytes. If any member crosses 64 bytes in your listpack set, it will automatically be converted to hash table. You can also check it, right? Config get. So we have 64 bytes. So basically every member in your listpack set should be less than equal to 64 bytes. If it's more than that, it will automatically be converted to hash table, right? So yeah, these were some of the encodings that Redis provides for set, which it uses to optimize memory internally. And yeah, these are some of the performance metrics. So you can add, remove, and check whether a particular member exists in a set or not. All these operations are O1. And also the scard command which is used, it's also O1, right? Because it just reads a counter. So whenever Redis stores a set, it creates a particular object as well where it stores everything, like what's the encoding, what's the type, and what's the length of that particular set. So checking length as well is like O1 operation. And if you want to see all the members of the particular set, it's ON operation, right? Because it returns everything which exists in your set. So it's not very optimized in Redis. And all the operations that we discussed, S union, S intersection, S diff, it's O and M in the worst case, right? And S, if you want to get any random member, it's O1, and S pop is also O1. So these are some of the performance metrics. As you can see, most of the operations are O1 and it's very highly performant, right? And there is one thing which you should remember: you should never use SMEMBERS on a very big set, otherwise it's going to block your Redis event loop. And make sure if you're using it in development or for debugging purposes, right? So yeah, and there are some other areas or scenarios as well where you should not use sets. Let's say you need an order in your set, you should not use it. You should use sorted sets for that, which we'll discuss in next video. And let's say you need values per member, like for every member you want to store some score or timestamp. You can't use sets because it only stores a particular element. You can't store combination of metadata to that particular element, right? So yeah. Just to recap, it's a unordered collection of unique strings, integers, and we almost discussed all the commands that set provides. You can do hands-on experience on this more. I'll also be sharing this notes link in the description of the YouTube video, right? Yeah, so I hope this video was good and you understood in depth how Redis stores set internally, and where in production you can use sets in various different scenarios, right? So yeah, I think that's it for this video, and in the next video we'll be covering sorted sets. So stay tuned guys. Thanks.